Let's look at 7.4b, angles between two vectors, orthogonal, parallel, or neither. So let's just review a little bit. It says graph the vectors and find the degree measure of the angle between the vectors. So this is 6, -2, and this one is -3, 7. So if we think about it, let's just go ahead and graph it. 1, 2, 3, 4, 5, 6, -1, 2. So that would be you. And then -3, 7. Well, there we go. And this is B. So we're wanting to know this angle right here. So we know it's obtuse. All right, so let's go ahead and find the dot product because we need to find the angle. So in order to find the angle, this was in our last lesson, we did cosine theta is the dot product UV over the magnitude of U times the magnitude of V. So let's go ahead and find all the components. So dot product is going to be 6 times -3, -18. And then -2, 6 times 3 is -18, plus 7 times -2 is -14. -32. Okay, so let's do the magnitude of U now. 6 squared plus -2 squared, square root of 40. Then we have the magnitude of V, -3 squared plus 7 squared, 9 plus 49, 58. Okay, so we have cosine theta is the dot product on top, and then the magnitude. Okay. So we need to find the angle, and we want the angle to be in the degree measure. So make sure we're in degree mode. So we're going to do inverse cosine of this guy right here. You're going to pull it down. So let's go ahead and go to the calculator. Make sure I'm in the correct mode, and I am. So second cosine, do the fraction. There we go. 131.634 is where we're going to go with. Degrees. And let's just make sure that makes sense for our picture. And it does, because that's an obtuse angle. So 131 seems right. All right, so now let's look at the next one. It says find the dot product of U and V, where theta is the angle between U and V. So remember our formula. Cosine theta equals the dot product times the magnitude of U, magnitude of V. Okay, let's plug in what we know. We know the theta, which it's in radians. We know the dot product. No, we don't. We don't know. So let's just go ahead and write that. And then the magnitude is 9 times 36. Okay, so it says find the dot product. So we find the dot product by, solving for it, using some algebra here. So I want to go ahead and look at what is cosine of 3 pi over 4. So get out your formula chart, your unit circle, and we are in radian mode. So 3 pi over 4, when theta equals 3 pi over 4, the values are negative square root of 2 over 2 and square root of 2 over 2. So it says cosine. So cosine is the x. So negative square root of 2 over 2 equals uv times 9 times 36, 324. And we want to find the dot product. So we're going to multiply both sides by 324. 324 times 2. So the dot product is negative 162 square root of 2. We're just going to leave it like that. And we could put it in the calculator. I'm not going to. I'm just going to leave it just like that. All right, so let's go to 5 possible orientations of 2 vectors. All right, so this first one, see how it looks like a straight line? There are vectors that are going opposite directions, but they are on a straight line. So this is when it's 180 degrees, it says theta equals pi. So think back to your unit circle. We are calling this parallel. Okay, the next one, it is when theta is between pi and pi over 2. So it is an obtuse. And what this says is the dot product is less than 0. It's going to be obtuse. Okay. If the dot product equals 0, it's going to be this right angle, which this is called orthogonal. Okay. The next one is an acute angle, and it is whenever the dot product is greater than 0. So that's going to kind of give us some ideas. It's going to give us clues. When we just get our dot product, we can find out, is it acute, obtuse, or orthogonal? Okay, then the last one is if they're going the same direction, just different magnitudes, then these are parallel. Okay, so the key thing here is for it to be orthogonal, the 2 vectors will have the dot product of 0. So our problems right here, the three problems that we have right here, it just says determine whether U and V are orthogonal, parallel, or neither. So we would need to check this first, do this first, and then if we need to, we'll have to find the actual angle. So let's look at number 3. U would be 2, negative 2, and V would be negative 1, negative 1. So let's do the dot product. So it's 2, I'm just going to write it out, times negative 1 plus negative 2 times negative 1, which would be negative 2 plus 2. So our dot product is 0. So all it wants to know is it orthogonal, parallel, or neither? This tells me it's orthogonal. And the reason is because think back to our formula. Here is our formula. If the dot product is 0, then it's going to be 0 or something. Cosine theta equals 0. So it is going to be theta is 0, parallel, theta 0. Cosine theta equals 0 because whenever it's making a right angle, that's what happens. So we don't have to go any further. All we have to do is say, okay, this is orthogonal. We don't have to continue any further. We know it's a right angle. We know theta is 90 degrees. Okay, so let's look at the next one. Dot product, 10 times negative 18 plus 20 times 9, negative 180 plus 180. The dot product equals 0. Again, so that means that cosine theta is 0, so it is orthogonal. We didn't have to go any further. All right, let's go to the next one. Let's find our dot product. Oh, that is not 0. So this is negative 102. So we need to go ahead and figure out the rest. So cosine theta equals negative 102 over. We need to find our magnitude. (15 squared plus 9 squared). That would be 225 plus 81, 0.6. (25 plus 9, 34). So this will be square root of 306, square root of 34. Okay, so we need to put this in the calculator. So in order to put it in the calculator, just like the one right above, we're finding theta. We're trying to find the angle. So second cosine, then do the fraction. Negative 102. And then square root 306. Guess I could put them in the same. It equals 180 degrees. So theta equals 180 degrees. So we know it's not orthogonal because the dot product was not 0. So then we've got to figure out, well, what is it? 180 degrees? It would be this one right here, which tells us they are parallel. All right, that is it. Come to class with your questions.